Hello everyone, I am Meenakshi Sharma and I welcome you all to lecture 2 of Ionic equilibrium. In today's video, we will learn about how to calculate pH of different kind of solutions. Before starting the topic, you should know the meaning of term ionization constant for water. So let's get started. Ionization constant of water. As you all know, water contains two ions, H positive ion and hydroxyl ion. So I am writing here the dissociation of water molecule. It produces two ions, H positive ion and OH negative ion. If this reaction is in equilibrium, the equilibrium constant can be calculated as concentration of product divided by concentration of reactant. If equilibrium constant is get multiplied to the concentration of water, the term comes to us is known as ionization constant for water. K into H2O is known as Kw, ionization constant of water. Or simply I can say that the ions present in water if get multiplied, the product that comes to us is known as ionization constant for water. At 25 degrees Celsius, it is practically measured that at 25 degrees Celsius, hydrogen ion concentration in water is 10 raised to power minus 7 molar. And as you all know, hydrogen ion concentration and hydroxyl ion concentration is equal in water. So water also contains 10 raised to power minus 7 molar hydroxyl ion. If I multiply the concentration of these ions, the product I will get is known as ionization constant of water at 25 degrees Celsius. That is 10 raised to power minus 14. It is Kw, ionization constant for water. Now, as the temperature increases, value of ionization constant also increases. Since ionization constant is also a type of equilibrium constant, as you all know, in endothermic reactions, if we increase the temperature, value of equilibrium constant increases. For endothermic reactions, if T2 greater than T1, temperature 2 is greater than temperature 1, then K2 will be greater than K1. Equilibrium constant at temperature 2 will be greater than equilibrium constant at temperature 1. And for exothermic reaction, the relation between temperature and equilibrium constant get reversed. If T2 is greater than T1, then K2 is less than K1. Or I can say that in endothermic reactions, value of equilibrium constant increases with increase in temperature, and in exothermic reaction, value of equilibrium constant decreases with increase in temperature. So as you all know, dissociation of water is an endothermic reaction. So if you increase the temperature, the value of equilibrium constant will also get increased. Hence, ionization product of water, ionization constant of water also increases with increase in temperature. It is practically measured that at 90 degrees Celsius, Kw for water is 10 raised to power minus 12, which is greater than 10 raised to power minus 14. I hope it is clear to all of you. So now, I am introducing you all with a new term, that is pKw. pKw is negative logarithm of Kw. Negative logarithm of Kw is called pKw. In chemistry, wherever you see P in front of a term, it generally shows negative log of that term. For example, pH is negative log of H positive, pOH of negative log of OH negative, pK is negative log of K, pKw is negative log of Kw. If I say P Meenakshi, it means minus log of Meenakshi. So in general, whenever you see P in front of a term, it replicates that it is negative log of that term. It shows that negative log of that term we will take. So pKw is minus log of Kw. So let's check the value of pKw at 25 degrees Celsius. pKw minus log Kw is 10 raised to power minus 14 at 25 degrees Celsius. So minus 14, you all may know about the property of log. Log m raised to power n is equal to n log m. Minus 14 will come in front of the log, it will become 14 log 10. And the value of log 10 is 1. The value of log 10 is 1. So pKw is 14 for water at 25 degrees Celsius. So let's start with next topic, that is dissociation of a weak electrolyte. You all may know that strong electrolytes are completely dissociated. Strong electrolytes show 100% dissociation. So concentration of ion is always equal to concentration of electrolyte. For example, if I dissociate NaCl, it will produce Na positive and Cl negative. Since it is a strong electrolyte, if I take concentration of NaCl C molar, the concentration of Na positive will be C molar and concentration of Cl negative will also be C molar. But in case of weak electrolyte, the concentration of ions are not equal to concentration of electrolyte since they do not undergo complete dissociation. So we should know about a term, that is degree of dissociation, which shows that how much amount of an electrolyte has been dissociated in a solution. Degree of dissociation. This term shows that how much amount of an electrolyte is dissociated in a solution. For strong electrolytes, degree of dissociation is 1, but for weak electrolytes, it is between 0 and 1. So what is the formula to find degree of dissociation? Degree of dissociation is denoted by alpha. Alpha is degree of dissociation. Degree of dissociation is calculated by number of moles of an electrolyte dissociated. Divided by number of moles taken. If these two terms are get divided, the term we will get is known as degree of dissociation. For example, if I take 10 moles of NaCl and all 10 moles get dissociated, so you will put 10 here and 10 here, alpha will be equal to 1. For strong electrolyte, they get completely dissociated, so number of moles taken and number of moles dissociated are always equal, and degree of dissociation is always equal to 1 for strong electrolyte. But for weak electrolyte, I have already told you in previous video that they show partial dissociation. They do not get dissociated 100%. Their dissociation is less than 100%, 70%, 50%, 10%. They show partial dissociation. So if I take 10 moles of an electrolyte and only 2 or 3 moles get dissociated, so let's check the value of degree of dissociation 2 by 10, that is 0.2. So weak electrolyte always have degree of dissociation ranging between 0 and 1. Degree of dissociation for weak electrolyte will be 0 and 1. So now I am telling you the way how to find concentration of ions for a weak electrolyte. I have told you that for strong electrolyte, to calculate concentration of ions, we should know about concentration of electrolyte, and generally the concentration of ions is always equal to concentration of electrolyte depending upon the number of ions. If there are 2 Na positive ions, the concentration will be 2C. If 3 Na positive ions, concentration will be 3C. The concentration of electrolyte is multiplied by stoichiometric coefficient of the ions and you will get the concentration of that ion in the solution. But for weak electrolyte, you cannot use this method since they are not completely dissociated. So let's start how to calculate concentration of ions in a weak electrolyte. For that, we need degree of dissociation. Dissociation of weak electrolyte. Suppose AB is a weak electrolyte, means it do not show 100% dissociation on dissolving into water. Since it do not get dissociated 100%, I think I can consider it as a reversible reaction, AB producing A positive and B negative. Suppose initial concentration of AB is C. Initial concentration of A positive and B negative will be 0. There will be no A positive and B negative ion in the solution initially. At equilibrium, some amount of AB will be converted into A positive and B negative. So suppose that amount is X. A positive will be X and B negative will be X. X is the amount dissociated from AB and converted into A positive and B negative. I have told you that alpha is equal to amount dissociated upon initial concentration. Amount dissociated X, initial concentration is C. So X is equal C alpha. So C minus C alpha, C minus C alpha, C alpha and C alpha. So now I know the concentration of different ions present in the solution of AB. A positive, concentration of A positive is C alpha, concentration of B negative is also C alpha, and the concentration of AB at equilibrium is C minus C alpha. So let's calculate equilibrium constant for this dissociation. Here I am denoting equilibrium constant as Ka. Ka, since you can simply write it Kd. Dissociation constant you can also tell it. Dissociation constant is found similarly as equilibrium constant is found. Equilibrium constant is found with the help of concentration of product and with the help of concentration of reactant. So to find dissociation constant, I will divide concentration of product with concentration of reactant. You can see here, concentration of A positive is C alpha, concentration of B negative is also C alpha, and concentration of AB is C minus C alpha. And you will find dissociation constant, C square alpha square. C is common here, so 1 minus alpha will be left. Kd is equal C alpha square. Now you all may are thinking that why I have left this 1 minus alpha. Since AB is a weak electrolyte, alpha will be less than 1. Alpha will be less than 1, so I can neglect it. So I have neglected 1 minus alpha here. So Kd is equal C alpha square. Or I can say that alpha is equal under root K by C. You can simply write it K or Kd. It's your choice. Alpha is equal root K by C. So alpha is inversely proportional to concentration. Degree of dissociation is inversely proportional to square root of concentration. If I increase concentration of an electrolyte in a solution, degree of dissociation will get decreased. Means the dissociation of electrolyte will be slow. So concentration and degree of dissociation are inversely proportional. As you all know, in equilibrium, concentration is equal to molarity, that is calculated by N by V, number of moles upon volume, since number of moles are constant. So I can also write here that alpha is inversely proportional to volume. Alpha is directly proportional to volume. Alpha is directly proportional to volume. If I increase the volume of solution, if I increase the solvent, water in a solution, degree of dissociation will get increased for weak electrolyte. So weak electrolyte show more dissociation on dilution, and this law is known as Ostwald's dilution law. What is Ostwald's dilution law? Ostwald told that degree of dissociation of weak electrolyte increases with dilution. If you add water in the solution of a weak electrolyte, if you increase solvent in the solution of weak electrolyte, the dissociation of weak electrolyte is increased. So now I have told you about the dissociation of weak electrolytes and about degree of dissociation. So now move to our main topic, that is how to find pH of different kind of solution. So first of all, I will tell you how to find pH of a strong acid. Calculation of pH for a strong acid is very easy. I have already told you pH is negative logarithm of H positive. It tells us about how many H positive ion is present in the solution. pH is equal minus log of H positive. As you all may see, pH is negative log of H positive, so pH is inversely proportional to H positive ion concentration. If a solution contains high amount of H positive, its pH will be low, and if a solution contains low amount of H positive, its pH will be high. And you have studied in class 10 that acids have pH ranging between 1 to 7 and bases have pH ranging between 7 to 14. Acids have low pH and bases have high pH, which simply indicates that acids have high amount of H positive and bases have low amount of H positive. So pH is negative log of H positive. pH is inversely proportional to hydrogen ion concentration. pH is inversely proportional to hydrogen ion concentration. Since strong acids are those acids which release a large amount of H positive ion in the solution, so they will have low pH. The pH of strong acid is generally low. So how to calculate pH of strong acid? You just need to know about concentration of H positive. You will take negative log and pH will be found out. As you all know, strong acids show 100% dissociation. The concentration of ion will be same as the concentration of strong acid. If the concentration of HCl is C initially, concentration of H positive is 0, Cl negative is 0 initially. When you see after a time, the concentration of HCl will be 0 and concentration of H positive and Cl negative will be C and C. Now, pH is equal minus log of H positive. You just need to know H positive concentration and pH will be found out. Let's take an example. Calculate pH of 10 raised to power minus 3 molar HCl. 10 raised to power minus 3 molar HCl. So before applying the formula, you should know that either your solution is aqueous or concentrated. If the solution is aqueous, you all should know that water also contains H positive ion. To calculate net H positive ion, you need to add H positive ion of water along with the H positive ion concentration in the acid. So there is a rule. If H positive ion concentration is greater than 10 raised to power minus 6 molar or equal to 10 raised to power minus 6 molar, you will neglect H positive concentration of water. If concentration of H positive ion is less than 10 raised to power minus 6, you cannot neglect H positive of water. You have to consider that. You have to take into the consideration H positive ions present into water. So as you can see here, concentration of HCl is 10 raised to power minus 3 molar. So concentration of H positive will also be 10 raised to power minus 3 molar, since it is a strong acid. H positive ion concentration is 10 raised to power minus 3 molar. Now, I will apply the formula of pH, that is minus log of H positive. Put the value of H positive here, that is 10 raised to power minus 3. I have already told you it's the property of log, that log m raised to power n is equal to n log m. It will be minus will be plus 3 log 10. Value of log 10 is 1, so pH is equal to 3. Here I will not take H positive ion of water into consideration because the concentration of H positive is greater than 10 raised to power minus 6. 10 raised to power minus 3 is greater than 10 raised to power minus 6. So let's take an example where we have to consider H positive ions present in water. Calculate pH of 10 raised to power minus 8 molar HCl. Here, I have to take H positive ion present in water because the concentration of H positive ion present in HCl is 10 raised to power minus 8, which is less than 10 raised to power minus 6. So I have to consider H positive ion present in water. So net H positive ion will be 10 raised to power minus 8 H positive ion concentration in HCl solution, and water contain 10 raised to power minus 7 molar concentration of H positive ion at 25 degrees Celsius. If temperature is not mentioned, you will consider the temperature as normal temperature, that is 25 degrees Celsius. So I am taking 10 raised to power minus 7 common here. 10 raised to power minus 1 plus 1. I can write 10 raised to power minus 1 as 0.1. 1 plus 0.1 will be 1.1 into 10 raised to power minus 7. This is H positive ion, and now I can easily find pH. pH is equal minus log of H positive. Minus log, put the value of H positive here, 1.1 into 10 raised to power minus 7. Now I am telling you a short trick to solve this kind of problems. Whenever you see minus log A into 10 raised to power minus B, it will be simply equal to B minus log A by using properties of log. So I am writing it here, 7 minus log 1.1. The value of log 1.1 is 0.0414. I am simply writing it 0.04. It will be 696.96. So pH of 10 raised to power minus 8 molar HCl will be 6.96. So this is all for pH of strong acid. This is the way how will you find the pH of strong acid. If the concentration is greater than 10 raised to power minus 6, you will neglect H positive ion of water. If the concentration is less than 10 raised to power minus 6, you will not neglect H positive ion of water. You will consider it, and to calculate net H positive ion, you will add H positive ion present in acid along with the H positive ion present in water to calculate net H positive ion. With the help of net H positive ion, you will calculate pH of the acid. So let's take another example. Calculate pH of 10 raised to power minus 2 molar H2SO4. Now the question arises, what is H positive ion concentration in H2SO4? Since H2SO4 is a strong acid, the concentration can be easily calculated with the help of concentration of acid. H2SO4 will break and form 2H positive along with SO4 double negative. If the concentration of acid is C, concentration of H positive will be 2C. So here concentration of H positive is 2 into 10 raised to power minus 2 molar. So simply calculate pH. Since it is greater than 10 raised to power minus 6, so I can neglect H positive ion present in water. Minus log of H positive minus log 2 into 10 raised to power minus 2. It is also the same form as I have told you. It will be equal to B minus log A, 2 minus log 2. The value of log 2 is 0.30. 2 minus 0.30 will be equal to 1.70. So this is all for today's video. In next class, we will learn how to calculate pH of strong base, mixture of strong acid and strong base, mixture of two strong acid, mixture of two strong base. So it's all for today.